Okay, so what we're going to be looking at here is a problem from 2017. This was number 3 on that test, and it's graphical analysis. And much like every other graphical analysis problem that we look at, I will say that you will not be using your calculator on this problem. Almost every graphical analysis one is a problem that you do without a calculator, and this one is no different. So let's go ahead and jump right in and take a look at this. Okay, we've got this graph of f prime. Now again, it's very important that we understand what it is we're looking at. So immediately I see, okay, I've got a graph of the derivative. Then it says the function f is differentiable on the closed interval from -6 to 5 and satisfies f of -2 equals 7. The graph of f prime, the derivative of f, consists of a semicircle and 3 line segments as shown in the figure above. Like most graphical analysis problems, there's not an awful lot of introduction. It is, although it's important that it's differentiable, we're actually not going to use that very much. But other than that, all I really have here is like an initial condition, and we'll talk about why that's important in just a second. Other than that, I really don't know. There's nothing much to look at, so let's go ahead and dive in to letter A. Now, letter A wants to know the value of f of -6 and f of 5. If you think about this for just a second, what this is really asking is, what is the original y value? And if you want to think about this in a particle motion sense, what is the original position at x equals -6 if I know that at x equals -2, the position, if you will, is 7. Now, what a lot of people struggle with on a problem like this is looking at it and saying, okay, this piece of information that I'm given, has nothing to do with this graph right here. Instead, that is an initial condition plus the integral from where it gives us that initial condition to where we actually want the value. So I'm going to go from -2 to -6 of my derivative. Again, if you think about this as a particle motion problem, this is like the initial condition plus the integral from a to b of the velocity. So when I do this problem, I get 7 plus, now I do have, or I guess I should probably make that a minus. I'm going to make that minus the integral from -6 to -2. If I look at that, that is a triangle right there. And that's what the integral tells us. So again, we're just doing what it's asking us to do. When I find the area of that triangle, it's 1/2 base times height. The base is 4. The height is 2. So really, you could leave your answer like this. That turns out to be 3. Now it wants us to do the exact same thing for f of 5. So I know it's 7 plus the integral from -2 to 5 of f prime of x, just like we had before. This time we're having to find the semicircle that's underneath the x-axis, and we're also trying to find that triangle. So I'm going to go 7 plus, it's half of a circle, so it's 1/2 pi. The radius is 2 squared, but because it's below the x-axis, I'm going to put a minus right there. And then I also have this triangle here that I'm going to have to add, so I get 1/2, the base is 3, the height is 2. When you simplify that, you could say again that it's like 7 minus 2 pi plus 3, if you wanted to simplify, or you could even change that to 10 minus 2 pi. So what I did here, again, is I just found both of those values. Now, that's a little bit tricky, again, because there's just no context in this problem. I actually think, well, letter C on this one's kind of tough, too. But letter B is actually really easy. On what intervals is the original function increasing? Well, that's just any interval that f prime is above the x-axis, because this is the derivative. So I would say from -6 to -2, always using x values to describe, and from 2 to 5 are the two different places. And the only reason I know that is because the derivative is greater than 0. That's it. That's all you have to say, and you have your answer for that particular problem. Now, letter C wants the absolute minimum value. Anytime you see absolute, you've got to go about doing that candidate test where we have to find all of the different x values of the function that are possibilities. Remember, that is, when we're looking at a minimum, I'm looking at this graph and I say, okay, at x equals 2, I've got a min there, so that's a possibility. The other two possibilities are my endpoints, and so I always want to find the x values, or the y values at those as well. So I've got -6, I've also got it +2, and I've got it 5. If you wanted to include -2 just because it crosses the x-axis there, that's fine, but you don't have to because that's a maximum, so that's obviously not going to meet the minimum value. So we already found in part A, we already found that f of x, so f of -6 was 3, And we also did 5. We found that was 10 minus 2 pi. Okay, if we remember, we simplified that down. That's what we got. So what I need to do now is just find the y value at x equals 2. We're going to do that the same way we did it before, where I'm going to go 7 plus the integral from negative 2 to 2 of f prime of x. Well, that is just that semicircle that's below the x-axis like we talked about before. So that is 7 minus 2 pi. So what I want to know is which one of those three numbers is the smallest. And it turns out that 7 minus 2 pi, you might have to use your calculator for that, but 7 minus 2 pi is the smallest of those three numbers. So that is the absolute minimum value, which is asking for a y value, on the closed interval. Again, the key phrase that triggers what you're supposed to do here is absolute. That's when you have to do that candidate test. Letter D I also find to be pretty simple. I want to find the second derivative when x equals negative 5. So right there, I want to find the second derivative. But what that's asking, because this is the first derivative, is what is the slope of that line? So I'm just going to go y2 minus y1 using any points that are on that line. To me, it makes the most sense to go, oops, that's wrong, 0 minus negative 6 over negative 2 minus, whoops, I did that wrong. 0 minus 2 over negative 2 minus negative 6. And you can leave your answer like that if you want to. That does simplify down to negative 1/2, but you can leave your answer just like this for full credits. Now for the second derivative in x equals 3, that's right there. And unfortunately, that one does not exist because we have a corner at that point. Remember, you can't take the derivative whenever there is a corner on a graph. So hopefully, again, those make sense on how to do those two. I definitely thought A and C were much harder than B and D on this one. But if you have any questions on this, please let me know.